Hello and welcome to my science tutorials, and in today's video we are going to be looking at logarithm. So let's get started. So logarithm, let's first look at the general form of logarithm. So we have log base a b is equal to c. So this is the general form of logarithm, and what this basically means per the rules of logarithm is that this can be expressed in the form b is equal to a raised to the power c. So where from this sudden transformation from here to here? Well, it so happens that if you want to get rid of logarithm in a certain equation, this whole thing can be transformed in a way. So to get rid of the log, you just have to make sure the a you have over here, which is the base, this is the base, okay, now carries whatever we have at the other side of the equal to sign as its power. Okay, so leaving this behind. So that is how come we have b is equal to a raised to the power c. So whenever we have anything in the form b is equal to a raised to the power c, this can come back and become what? A base, and then we introduce a log. So this will also give us what? So if the a comes back and becomes a base, we have log base a, then we still have our b, then our c, which is the power over here, becomes the bigger c. So this is the general form of logarithm and how to actually change it. This form is very useful, so we are going to see how it's used. And then one thing we also need to take note of is the fact that log always has a base. It always has a base before we have a variable here is equal to another variable. So assuming you have log 5 is equal to maybe, let's say, 10. This implies that over here the base we have over here is 10. So the standard base of a logarithm, if the base is not given to you, is 10. So let's take note of that. So log base 5 is equal to log base 10 raised to the power log base 10 5. So this and this are equal. So with this basic introduction, let's have a look at the laws of logarithm. So laws of logarithm. So let me make it short. Laws of log. So the first law of logarithm is the addition law. So I will say addition. Usually addition and multiplication goes together, and then subtraction and then division also goes together. So this technically works in log 2. So if we have log base a x plus log base ay, this will be equal to what? Now whenever we have addition between two log raised to the same, having the same base, the only thing we do is we tend to multiply the x and then the y, and then we have just one of the log. We repeat one of the log. What do I mean by this? So we have this to be equal to log base a then x y. Okay, so this is the first law of log, which is the addition law. Now mind you, the same way, if you have log in, let's say log base a x y, okay, you can also write this as log what? Base a x plus log base a y. Okay, so it is reversible. You can go the forward way, which is in this direction, or you can go the reverse way. They are all the same thing. So let's have a look at an example. So an example here is log in base 2 3 plus log in base, let's say 2 2. So this, per this law, will give us what? Log in base 2 into bracket 3 times 2. So this is equal to what? Log in base 2 6. Okay, so this is how we solve a log question, assuming we are given and it has a positive sign within it. So let's have a look at the second law. So the first law is what? Log in base ax plus log in base a y will give us what? Whenever we have an addition sign between two logs, we tend to what? Multiply the two variables that we have in front of the log. So let's have the second law. Now the second law, also known as the subtraction law, is just the same as the first law in the sense that we have log in base a x minus log in base a y. Now, like I said earlier, when I told you negative sign always go with division in terms of log and most mathematics equations and solvings. So here we have log base a, then we have the ratio of x to y as the answer in case we have this. So we can express this in this form. So assuming we have this, let's say log base a, then let's say, let me use a and b over here. This can also be expressed as what? Log in base a capital A minus log in base a capital B. Okay, so yeah, so it is reversible. You can go this way or you can come back this way. So let's have a quick example of that. So we have log in base 2 21 minus log in base 2 7. So this will be equal to what? Log in base 2 21 divided by 7. So this will be equal to what? Log in base 2 21 divided by 7 is 3. So this will be our answer. So let's take note of that. So this is the second law, the subtraction law. So the third law, which I don't know whether we have a specific name for that, so I won't deceive you guys by saying anything. So if we have log in the form log base a x raised to the power n, whenever we have, let's say the log with the base is, let me say, a constant, so let's just ignore that for now. So whenever we have the variable in front of the log having a power, we can bring the power in front of the log before we write any other thing over here. So what I mean by this is, here we can express this as n log base a x. This is very useful when we are solving log equations and then anything that has to do with log. So we have to take good notice of this. It is really important. So assuming we have for example log in base 2 5 raised to the power 2, which is technically let me say log in base 2 25, and we decided to express it as log in base 2 5 square. This is equal to what? 2 log in base 2 5. Okay, so this is how we apply this law. So log having a number raised to a power, the power can be brought in front of the log, and then we have the log being written back again. Now the last law we want to look at before we try some few examples is the change of base, the law that involves the change of base. So let's have a look at this. So whenever we have a log in base, let's say ax, okay, and let's say we want to solve this, and then we want to express the log in a different base. We want to introduce a new base. What do we do? So if we are introducing a new base, sorry, and let's say we decide that base should be base b. So what we have over here is that we tend to have this will be log base b, which is the new base we want. Then the s we see is at the top over here, so it will still be at the top. Then we divide it by the log of the same base b, and then this will now become like a variable. It will now become like the way the x is over here, it will be there. Okay, I know this sounds a little bit tricky at first if you are new to logarithm, but then trust me, with time you get to know how to use the change of base law. So with these four laws of logarithm, let's get started. And yes, before we start solving examples, we need to take note of the fact that if we have log in base a, and then the value we also have here is a, then this is equal to 1. So for instance, if we have log in base 10 10, this is equal to 1. So if we have log in base, let's say 2 2, is also equal to 1. Log in base, let's say maybe 100 100 is equal to 1. So whenever we have log in base a log in base b, it is always equal to 1. So let's have a look at some few examples to actually enhance our understanding of this introductory course to logarithm. So quickly here, let me get an example from my reference book. So we have log root of 3 27 root 3 as our example. Now mind you, the root 3 here is the base, so let me rewrite this so that it will not confuse you guys. So so I have here log. Now the base I'll be using yellow. Root 3, and then we have 27 ish 27 root 3. Okay, so how do we solve this? Now when we are given such things to solve, we first of all want to say this, let this whole question be equal to, let's say, x or y or anything. Now once we have this is of the form log base a, let me say b, the entire b will be what? 27 root 3 over here, we are representing it with b, is equal to what? X. So from the first law that we saw already, we can say what? B is equal to a power x. Okay, if you understand the first law that I explained earlier. So from here we can write the whole of this as what? The root 3, which is the base over here, will not carry the x as its power. So we have 27 root 3 is equal to what? Root 3 raised to the power x over here, using the first law of logarithm. So from here, what do we need to do? We just need to simplify things up for ourselves. So now root is power half. Okay, so whenever we have a root sign, it's power half. So because we have 3 here, let's express 27 also to have like a radical. Let me say it should have a base and then an exponent. So we have 3 raised to the power 3 will give us a 27. So we have that multiplied by this is equal to what? 3 raised to the power half. So any number power half is the root of that number. Is equal to this will also be what? 3 power half. But mind you, there is an x at the top over here, so it will be multiplying the x. Okay, so from here we have this two things over here. So now because there is, look, this is multiplication. Okay, so once we have multiplication, we have the same base, we tend to add the exponent indices if you still have your indices alive. So we have 3 raised to the power 3 plus half is equal to 3 raised to the power 1 over 2x. So over here let's solve just 3 plus half separately. So we have the LCM to be 2. Here is 1, so it will go here 2 times this is 6, plus 2 go here 1 times 1 will give us 1. So this is what? 7 over 2. So we have here 3 raised to the power 7 over 2 is equal to 3 raised to the power half x. So from here we can see that we have the same base, so we ignore the base and then what? We equate their powers. So from here we have 7, so from here is equal to 7 over 2 is equal to what? 1 over 2x. So let me quickly get some space at the top over here. So from here we can just finish the solving. So yes, so from here we multiply both sides by 2, which is the LCM. So If we do that, we have 2 times 7 over 2 is equal to 1 over 2x times 2. So this will cancel this. We have 7 is equal to this. We'll cancel this. So we have 1x, and 1s is technically s. So the value of our x, or the value of this whole thing, is equal to what? 7. But mind you, you said at the beginning of the equation that let log of all these things should be s. So now that you have x to be 7, just write for the lecturer to know, or the teacher to know, log of root 3 27 root 3 is equal to what? 7 as your answer. Okay, so let's have a look at more examples for logarithm. So example number 2. So let's have a very simplified one. Log base x 64 divided by log base x 4. Now once we have this, okay, now if something should, like, whenever you have something like this, try to always see if you can express this is the smaller value 4. So can we have any, like, 4 raised to any power that will give us 64? That should always come to mind in case you have something like this. So it so happens that in this case exactly we have something that will give us that. So 4 raised to the power 3 will give us 64. So this will be equal to what? Log base s 4 raised to the power 3 divided by what? Log base s 4. So from here, now if you look at the third law of indices that I showed you, that is log base a b raised to the power n. I told you we can write this to be what? N log base a b. So from here we are going to write the same thing. So the 3 will now come here. So we have 3 log base s 4 divided by what? Log base x 4. Exactly. So from here you can see straight away that our 2 log base s4 will cancel out. So we have our answer to a 3. So this is how we solve an equation involving the ratio like that. So let's quickly jump into things, and then let's start having real fun with logarithm. So we want to solve some 3 equations of logarithm. So we are looking at equations involving logarithm. Let me short it as log. Okay, so we are going to make use of all the 4 rules or the laws of logarithm that we've studied so far. So if you have them jotted somewhere, be looking at them. You are going to use them, and we are going to have fun. So the first question is we have log base 10, then we have into bracket s square plus 1 minus 2 log base 10x is equal to what? 1. So this is interesting. So how do we solve this? Well, first of all, this is like log base ab, so we can repeat that. So log base 10 s square plus 1 minus, now does this look like something familiar? Yes, it does. Okay, so this actually, what we have over here, is of the form log base 10 s square. That is how come the 2 came here when they were simplifying it to have this. So from here we can go back to this form. So that is so that is what we are going to do. So we will have the 2 becoming the power of the s we have over here. So we have minus log base 10 s square is equal to, now remember I told you, any, like, if we have log a is equal to 1, yes, so because we have 1 over here, okay, and then the base we are working it is 10, we can assume that the 1 over here is not just any ordinary 1, it is what? Log base 10 10. Okay, so in place of 1 over here we are going to have what? Log base 10 10. Now beautiful. So now that we have this, we need to take note of something. Can we see there is a subtraction sign over here? Exactly. So second law of logarithm, whenever we have subtraction, what do? We divide. Okay, so this whole thing is going to be log in base 10, then we have s square plus 1 divided by what? S square is equal to what? Log in base 10 10. Okay, so you can see over here we apply the third law of logarithm. Over here we applied the second law of logarithm. Okay, so yeah, that is how easy logarithm can be. So from here, okay, we have log base 10, log base 10. So what we do is what? We take antilog of both sides, antilog of both sides. Okay, so when we take antilog of both sides, antilog means like negative, like maybe 1 over log, so the logs will cancel out over here. So whenever we take antilogs of log, we don't have the log again, so the log will disappear, magically disappear. That is math for you. So instead of having log over here, okay, we are going to be having s square. We'll be having s square plus 1 divided by s square is equal to what? 10. Now this is beautiful. This is now in a linear form and we can solve this straight. So we just cross multiply. So we have s square plus 1 is equal to what? 10x square. Okay, so we now just group items and then we solve our equation. So we have 1 is equal to 10s square. Then we bring the s square over here to the other side of the equal to sign, so minus s square. So we have 1 is equal to what? 9s square. Okay, so we divide both sides by 9, so we have s square is equal to what? 1 over 9. But we are looking for x, not s square. So I hope you guys are done with this side in case you are copying. So yeah, so we have from here s square is equal to what? 1 over 9. So the 1 over 9 we have over here, we just have to take root of the s square, then root of 1 over 9. So this will cancel this. So we have s root of 1 over 9 is equal to what? 1 over 3. So the value or the answer for the question I gave over here is what? 1 over 3. Mind you, we take root sign, so it can be what? Positive or negative, plus or minus 1 over 3. That is if you take root sign of any value. So yes, so this is our answer for question number 1. Awesome. So let's look at another example. So example number 2. So we have 3 log base 10x plus log base 10 3 is equal to log base 10 81. Now this is beautiful. We can see from here we have the third law of logarithm, so straight away we go. So we have log in base 10 s raised to the power 3 plus log in base 10 what? 3 is equal to what? Log in base 10 81. Okay, so we can see we have the first law of logarithm over. So from here we applied the what? The third law of logarithm. From here we can see that we have the first law of logarithm, that is the addition law. So we have log in base 10, then we have this will multiply the 3, so we have 3s cubed is equal to what? Log in base 10 81. So whenever we have something like this, we just take what? Antilog of both sides, antilog of both sides, antilog of both sides. So the logs will go away. So we have 3s cubed is equal to what? 81. So from here we divide both by 3, both sides by 3. So we have s cubed is equal to 81 divided by 3 will give us what? 27. So from here we just have to find x. So we take cubic root of x is equal to what? Cubic root, this is supposed to be cubic root of 27. So yes, s cubed, sorry. So this will cancel this. So we have x is equal to cubic root of 27 is what? 3. So yeah guys, this is basically how we solve logarithm equations and a basic introduction to logarithm. If you have any other question you want us about logarithm, you can ask in the comment section below and I'll be sure to answer you. And then if you are new to this channel, don't forget to subscribe, and then I'll see you in the next video. Thanks for watching.